Hello and welcome to Thinking in Fusion. This is session 7, where we'll be looking at special effects and saving and loading files. I'm Adam from Impact Gamers, and over the previous sessions we've taken you through the basics of using ClickTeam Fusion 2.5, the free edition and the full edition, to make your very own game. As always, we'll start off with some quick summaries and then go more in depth later on. This way you can watch the first section, and if anything interests you, you can then jump forward and look at the in-depth section.
We've got a lot to get through in this one, lots of topics. Transparency, how see-through things are, RGB coefficient, when you tint things, ordering, positioning on screen, effects and particles like dust and dirt, video, saving and loading data, and then as we go more in depth with it, we look at alpha blending with the transparencies, palettes for the RGB coefficients, how to make explosions that don't take up too much memory, effects with layers and parallaxing and screen shake, video and how to get your codecs to work, loading and saving with INI files and with your own custom list.
Can you see me? Can you see me now? When building a game in Fusion 2.5, understanding what things control transparency is really important. For most objects, in their Properties toolbar, under Display Options, you have a checkbox, a tick box, saying Visible at Start. This allows you to have the image shown or not shown at the start of frame. This visibility can be controlled in the event editor. You could add an event, the keyboard, upon pressing a key, spacebar, then under the object, right-click for an action, visibility, make object reappear, or you could choose to flash the object. That is one form of transparency, either fully visible or fully invisible. But also, for most objects, in the Properties toolbar, under Display Options, you can change the blend coefficient. This is a number that varies from 0 to 255 for how transparent that object will be. 0, by default, is fully opaque. 255 is fully transparent. But any number in between is partially transparent, allowing you to see objects that are below it. This operates independently, separately from the visibility. You can have something semi-transparent, maybe at 200 blend coefficient, but you can still change its visibility to be invisible or visible. This is useful if you want to have a section of a game that looks like the lights are flickering on and off. You could use this for fog or smoke, but we'll look at particles in a later section at this timecode. Also, we're going to look at separately arranging objects, making sure that your object is in front of other objects to get the desired effect at this timecode.
While looking at transparency, I want to cover about transitions. Transitions work on frames or on objects for when they appear, start the frame, or are created in frame, or when the frame finishes, or the object gets destroyed, it fades out. Now these transitions only work on Windows. They don't support transparencies or alpha channels, so they dither or pixelate. So it'd be extremely rare to use these in a final published game, but for making something quickly, they work fine.
Let's look at RGB coefficients. RGB coefficient stands for red, green, blue. White light is made up of red light, green light and blue light on a computer screen in equal amounts. And these are numbered from 0, nothing, to 255, fully on. So red, fully red, would be R, 255, G, 0 and B, 0. All the reds, no greens and blues. Yellow would be R, 255, green, 255, B, 0. No blue. You'll find the RGB coefficient for most objects. It's in the Properties toolbar, Display Options, under Effect. The RGB coefficient is the same as lighting up an object in the real world, only using one colour of light. So if I have a white object, and I light it up just with blue, it will look like a blue object. But if I have a green object and light it up with a green light, it won't look any different. The RGB coefficients can be changed in the event editor and have to be set in a certain way. So on this image, I'm going to set it that when I press the R button, it just lights it up red, G, just green, and B, blue. So upon pressing R, I want to right click for an action under the object, Effect, set RGB Coefficient. Now unfortunately you don't just type the numbers in, you need to use a function called getRGB. You can find this under the cogs for special, colors, get RGB value. For the red value, I'm going to do 255 and press tab and enter 0 for green, press tab and enter 0 for blue. Press OK. I'm going to drag and drop that down for the green, edit it and change it to 0 red, 255 green and 0 blue. And for blue, it'll be 00255. Now if I run my application, I can switch between the different colors of lights and that object will be lit in different ways. And you can find out more about this in the advanced section here. Arranging items. If you're like me, you're not very good at arranging things, and most objects in your house will end up on the floor. In ClickTeam, level creation can get very crowded, and you'll have other objects on top of other objects. To change those orders, you can right-click on an object and click on Order. You can bring it to the front, so it's above everything, or to the back, or move it forward one or backwards one. You can also order it by the X coordinate or the Y coordinate, meaning this works if you have selected multiple objects, you can order them all at once by how far away they are from the edge of the screen, either increasing or decreasing. Increasing Y means things will be in front the lower down they are, and for X, increasing the further to the right. Now arranging can become very difficult as you add more complexities or background images or foreground images, and you can use the event editor and an always condition to position things to the front or the back. But there's a much better technique you can use with the layers, and we're covering that at a later section. At this timecode, now we're going to look at effects. Effects. This is where ClickTeam can be expanded hugely. You can download different shaders and different effects as add-ons. I'm only going to cover the two basic ones that come with the free version, addition and subtraction. The addition effect behaves in the same way as it would if you were to use it in Photoshop. If you have an image which has light colours, sort of white colours on it, and it has an addition effect on another image which is dark, the white image will lighten up the dark image. And for subtraction, the opposite, the white image would darken the dark image. The closer to white the pixel is, the more effect it will have, and the closer to black it is, the less effect it will have. So to demonstrate this, I'm creating an active object that's going to be a circle in mid-grey, so it'll have a medium effect on addition or subtraction. I'm also adding a backdrop of an image. Under the Properties toolbar, for the active object, I'm choosing the effect, which is None, and Editing. I'm opening up the standard shaders and I'm choosing Add. And you can instantly see the effect that the image is lightened where the circle is. Now if I click on Effect and choose Subtract, you can see it's darkened that image, no matter where it's moved. Addition and subtraction are the perfect way to add a flashlight or a torch into your game. We'll look at this in depth at this timecode. Particles. Now particles are specks of something, or blobs of something. Things that are created normally on an impact or for an effect in a video game. The classic one may be in a racing game. As the car goes through the mud, mud particles are thrown up in the air. Or by a fire, smoke particles. Now in ClickTeam, there is just one object to use as particles. In the advanced section, we'll look at a better way of using active objects to behave like particles, which is less processor intensive, allowing for more particles and more control over them. So if we insert a new object, it's called physics particles. Place that in your frame. Now when you run your frame, it will remind you you need to have a physics engine object. So also add one of those in too. And a reminder, the physics engine is a set of code that's invisible to the player, but I'd still place it outside the play area so it doesn't interrupt with your level design. Now if we run our application, multicoloured balls shoot from the physics particles. You can change if it emits from a point or from an area, and you can alter creation speed and images. These will be covered at the later section. One thing I'll do now is change the initial speed to be lower, change the gravity, I'll limit the amount of angles so it's just upwards, and change the gravity. I'm going to edit the particle image to just give it one, not an animation of different colours, of some smoke. It's a PNG image which has alpha transparency saved into it, meaning some parts of the image are more transparent than others. Now if I run this, you'll see that it rises upwards like smoke. But again, look at the in-depth section at this timecode to find out more about these controls.
Video. Adding a video into a Fusion application is quite simple, but there's several different objects that do it. The different objects show videos either for different platforms or in different ways, and are only available in the full standard edition or developer edition of Fusion. Active Direct Show is the most versatile video player, but will only run on Windows systems, so it'll run in your test application or if you build your game as a Windows executable exe file. When placed down, it will ask for which video file you want to play. By default, it'll show AVI, but as this is a Windows multimedia player, it should play any video file that Windows can play. See the in-depth section about this. And because it's an active object, we can apply movement, or ultra-raw values, or an alpha blending coefficient, any feature that you would use of an active object. In the event editor, we have play actions where it can load a new file, play, stop or close, or you can set the position of the player, the speed of the playing, and the volume. Be aware these stop and position are to do with the playback of the video, not to do with the movement or location on screen. These are the video options.
In your game, you might want to save points, meaning the player can quit the game, restart the game, and carry on from where they were. Or you may want it that it remembers the player's name. So every time they play the game, it will welcome them. All the variables, even the global variables in a Fusion application, get reset when you run the application. So you have to save a file on a computer in order to keep any data you might want. So let's look at loading files. In the free version, the list and the formatted text are the objects that can load files. The list will display them line by line, and the formatted text will display it as if it's a document. So if I make a text file in Notepad and write my name, and then maybe a number, then in the event editor, a new condition at start of frame, I can add an action for the list under Files, Load List File. I then get a File Explorer up and I can locate the file. Now it's far easier if you save your files in the same folder that you're building the game. So I choose that example text document, and when I run the game, it will load those two lines as separate lines of the list. If I open WordPad, I can add formatting, I can add font, I can change the colour and size. And I can write some information down. I'm going to save that as an RTF file, a rich text format file, and then at start of frame, I'm going to right click under formatted text, I'm going to click on load, load new text, select this RTF example, and when I run it, that's displayed. In the full versions, you can also do this with combo boxes. You can use it with a rich edit object, which is like formatted text that you can change, the edit box, and the ini object. So please check out the in-depth section at this timecode. I'm going to show how to save the list. We're going to set up a new condition that when I press A on the keyboard, it will change the lines on the list. And then I'm going to set another new condition that when I press S, it will save it. And I'm going to save it on top of the original example.txt. So I run my game, it loads the original example, I press A, and it changes the list. But if I reset my game, it will go back to what it was originally. because the file hasn't been saved. So this time I'm going to press A to change what the list says, and now I'm going to press S to save the list. Now if I restart my application, it will reload the new saved example text. Just be aware that lists are always strings, so check back to the string section, not that one, the string tutorial section on this video at this timecode to look at converting strings so they can be used in counters. That's all the summaries. Let's go in depth. So let's look at alpha blending coefficients in depth. Alpha blending coefficients, as we said before, is a number between 0 and 255. Anything 0 or below is fully opaque, not transparent at all. And anything 255 or greater is completely see-through. The default alpha blending coefficient can be set, as we said in the summary, in the Properties toolbar, in the Display options, under the Effect category, Blend Coefficient. The alpha blending coefficient becomes very useful in the event editor when you start to use variables instead of values. A basic example would be in the event editor, adding a condition every 1/100th of a second, add an action under the object, right click, Effect, Alpha Blending Coefficient, and in the expression editor, you can select that active object, get the Effect Alpha Blending Coefficient current number, and add 1. When we run it, it will fade out over time. Now to make that much more useful, we use alterable values. So check back to this session about alterable values. So rather than immediately changing the alpha blending coefficient, we can set up an alterable value, which we'll name fade, and every 1/100th of a second we will add to fade, and a new condition always, right click on our active object, effect, set alpha blending coefficient to be the alterable value fade, and we run it and it works in the same way. But now we can change what affects the fade. I'm going to right click and inactive the line of every 1/100th of a second. I'm going to change that. I'm going to say new condition. It's always. Under the active object, I'll right click for an action, alterable values, set alterable value, fade, and I'm going to set it to the active object, position, distance with a point. And I'll use the X and Y of the cursor. So the closer the cursor gets to the active object, the lower the value fade is, the lower the alpha blending coefficient is, the more visible it is. And if I wanted to reverse that, I can go back into that action and I can right click and edit it, and I can make it 255, remember that's the maximum, minus the distance with a point. That way, the closer you are to it, the more see-through it becomes, and the further away you are, the more opaque. Now, as a little aside to this, we can start to use curves. You can use logarithmic curves, but one curve that's especially useful is a mathematical curve called the sine curve, or sine wave. But it's often abbreviated to 3 letters, so it looks like the word sin, but pronounced sine. The sine function takes a value and changes it into a number between 1 and -1. When the value inputted to sine is 0, it comes out as 0. But if it's 90, it comes out as 1. 180, it comes out as 0 again. 270, it comes out as -1. And 360, a full rotation, is 0 again. And it repeats, but with a nice, smooth curve, the sine wave. So what I'm going to do is set the active object to have another alterable value. This time I'm going to call it sine count. Then I'm going to inactivate the other condition about distance. I'm going to insert a new event, and this time it's going to be that every 1/100th of a second, under the active object, I'm going to alterable value, add to alterable value, sine count 1. So sine count will start off at 0, then it'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and keep on going. I can then right click on the same tick and set my alterable value of fading, can be the sine of that sine count. But that will only give me a number between 1 and -1. So I need to times it by 255. So I'm going to add 1 to it. So it'll give me a value between
0 and 2. And because I want a number between 0 and 255, I'm going to times that number by 128. And now it'll smoothly fade out and fade back in. The sine wave is so useful, I've got a little aside about how to use it in different scenarios. If I want a coin to look like it's spinning, I can change its x scale, its width, to change along with a sine curve. So I'm just going to inactivate the fading in and out from earlier. I'm then going to, on the every 100th of a second, I'm going to right click another action for that object, scale angle, set x scale. Now this wants a value between 0 and 1. So what I'm going to do is set it to be 0.5. That's half a width. I'm then going to add to it the sine of, from the active object, the sine count, and times that number by 0.5. And for speed and quality, we might as well go for quality, so we'll put a value of 1 there. We can see that the object now slowly looks like it's rotating. But when it gets to an x scale of 0, 0.5 minus 0.5, it disappears completely.
So let's break down this expression to see how it works. The first number I'm going to change to 0.51 and that multiplication at the end to 0.49. And let's look at the effect. The rotation speed's exactly the same and the width is the same apart from when it gets to the smallest size. So let's look at why that is. The first number is the average size of the coin and the last number is the amount it changes by. So because it's 0.51 and we're subtracting at the smallest 0.49, we're still left with 0.02, 2%. And its biggest 0.51, add 0.49 becomes 1. So it's never going wider than 100%. Now to change the speed, all we do is we add a multiplication inside the sine function. Times 4 means that when we run it, it will spin 4 times as quickly. And if we wanted it slower, we could times it by a number lower than 1.
And this sine can get used within lots of different aspects. This object, I've got the sine affecting the whole scale, but I've done it to a much lesser degree. I've set the average as 0.9, and I've set the multiplication of the sine to be 0.1. So it's actually ranging between 0.8 and 1, 80% and 100%. I've also times the sine count by 0.5 to make it much slower, more pulsating. And here, I've added the sine curve into the Y position of the object. So at the starter frame, I'm getting the active objects to remember their Y position in an alterable value. But then, as the sine count increases, I reset the Y value of the object to its alterable value of its starting Y position, plus the sine of the sine count times by 2 to make that a bit quicker, and then times the whole thing by 15 to allow 15 pixels up, 15 pixels down, a difference of 30 pixels as it floats up and down. Can really add a nice effect in 1 or 2 lines of code. So I think we've signed enough, so we'll go back and look at the RGB blending coefficient. There's not too much to add for the in-depth section of RGB coefficient. In the summary, we've covered most of it, but there's a couple of features I just want to highlight. You can actually set the RGB coefficient of the whole frame in the Properties window in the Settings category. Also, you can change it in the Event Editor under Storyboard Controls. And finally, you can get the RGB values of any pixel on screen. So for example, I have a colour palette here, and I have an object that I'm going to change the RGB coefficient of. I'm going to say that when I click under the object I'm lighting, I'm going to right click, go to Effect, set RGB coefficient, then choose the colour palette, get RGB at, and then under the mouse, get the X position, press Tab, then under the mouse get the Y position. Now by clicking on the palette, it will adjust the RGB coefficient of the object. I talk about lighting when I talk about RGB coefficient because it's the effect of the colours lighting up the object. But if you want something to shine through in a certain way like a rainbow, then just use the alpha blending coefficient
or you can use the addition or subtraction shaders, covered at this timecode. Now let's look at some special effects. Firstly, we'll look at a little explosion. Particles can work well for this. We can set up a particle emitter by inserting a physics particles object into your frame. Now, with any physics, we need to add a physics engine object in, so I'll add that in also. Let's look at the adjustments we can make. So under the settings, I can choose from a point. That will work well with an explosion. The other option is from a zone, where I can resize it that particles can spawn at any position in that area. Now, from a zone is really useful if you're creating something that's coming from a cloud, so maybe snow or rain. For create particles at the start frame, I'm going to leave that on. Creation speed is how quickly particles are made. Number is the amount of particles made at that speed. Angle is their initial direction they set off at. And the angle interval, how much inaccuracy there can be from these set angles. Initial speed is how fast they set off. The speed interval is the variation of speed. Then you have initial torque, which is a spinning force. You can apply force, so it keeps on moving. And you can apply torque, so it keeps on spinning. So think of these initial speeds, initial torques as impulses, and the force and torque the same as normal, covered in the physics section, which we've already covered when we've talked about physics movement, in this video at this timecode. So I'm going to make adjustments to this so that the explosion happens quickly. I'm going to add my own animation and set the animation speed, and it's not to loop. So it starts off bright white, goes through orange, yellow to red to black. Scale, I'm going to set to a minus number, so it decreases the further it gets away. I'm not going to have any friction because it's not going to collide with anything. No elasticity. Gravity. If we were having something like snow, it would have extremely low gravity or possibly no gravity and just have initial directions of coming downwards. And with density, I'm just going to be careful because as I change the density or the size of the image, I am changing the amount of force needed to move the object. So if you start editing your density later on, you'll need to readjust the forces and speed you've done earlier. And I have a choice of destroying it at the end of the animation or its distance in pixels from its center point. I'm going to go destroy at end of animation. And then with all physics, I can apply which physical engine the ID applies to. And this will have the default engine ID of 0. Now, as you can see, my explosion is constantly exploding, which is really useful for me to see if there's any adjustments to be made. So let's close the test application and go back to the particle settings and turn off create particles at start of frame. Now in the event editor, I'm going to have it that if I click on this active object, it gets destroyed and the particles will show the explosion. So in the event editor, new condition, the mouse, user clicks on an object. Then I have two choices about how I'm going to have the particles. Am I just going to have one particles object on screen that I reposition to each explosion? Or am I going to create a new one? I'll show you the simple way with positioning first. So I'm going to right click under my particles, position, select position, and relative to, and choose my object. Then I'll right click under the particles, then create destroy, create particles, and choose the number of particles I want to create. Now, this is important. When you create particles, these are all created at the same time. Your settings about creation speed and number are ignored from the physics particles object. And I'm going to destroy my active. Let's test it out. Run application. And I have this effect. So let's look at the more advanced way of doing it, giving us more control. So this time, I'm not going to reposition. I'm going to go under the create column and create new object. So I can create the object, the particles, and that can be relative to the active object. Or if the explosion was coming from my click, rather than create object, I can create object at and use the X position of the mouse, the Y position of the mouse, and just put it on the layer that I'm looking at. We're going to cover layers shortly at this timecode. Then for my particles, for an action, because I've turned off the properties to create the particles from start of frame, without checking that box back, I'll have to turn them on manually with an action. So under particles, particle creation, sets automatic creation on off, and then I use 1 to turn it on. I can then destroy my active object. If I run that and click, the explosion will keep on happening wherever I click. If I do that, you'll see as before, the particles remain. And my object count goes up. So what I'm going to do is I'm going to close my test application, and in my physics particles, I'm going to give it an alterable value, and I'll name that lifespan. And I'm going to set the initial value of that to be 30. In the event editor, a new condition to do with the timer, every, and we'll say 2/100ths of a second, under the physics particles, alterable values, we're going to subtract from that lifespan 1. So this is going to allow us to turn off the particles. New condition, alterable values, compared to one of the alterable values, lifespan is equal to 0. Now if we destroy the physics particles emitter at this point, it destroys all the particles that are there. So it'll be a very sudden disappearing of particles that have only just been created. So what we'll do is we'll turn it off first. So I'll right click, under the physics particles, under particle creation, set automatic creation on off, and we'll set it to 0. Now, that means that the particles will stop being emitted, but the object will still exist. So to clear up the memory, a final event, new condition, physics particles, compared to one of the alterable values, time span, lower or equal, and let's say -60. And then we can destroy the particle emitter, knowing full well that all the particles that have been created at this point will have already been destroyed because they've reached the end of their animation. This leads to a much nicer effect. Particles have a lot of maths happening in them. This allows you to check in the event editor and new conditions to just see if a single particle collides with something, or leaves the frame, or even loop through each particle. Refer back to the counts and loops section in this video at this timecode.
You can check for a particle colliding with a backdrop or an object, and you can choose it to stop,
giving a more realistic effect, like this. All this maths and calculations means that when there's a lot of particles on screen, the game can slow down. Now this doesn't happen as much for active objects. So in this game, I've got a character that lands in snow. Every time they hit the snow, some particles are created, but this is causing the game to slow down. I can emulate particle creation by setting up an active object, and the active object can be set up with movement of bouncing ball, or with physics static or physics bouncing ball to get the right movement out. And then in the event editor, I've got an alterable value on my character called snow dust. When they hit the snow, I set it to a number. When the snow dust is bigger than 0, I decrease it by 1. I create the active, and every 100th of a second, I'm adding 1 to the life of the snow dust and decreasing its scale by 90%. When the life of the snow dust gets high enough, I destroy it. When you're doing snow or rain effect, here's a technique that works well. Rather than setting out the particles from a zone and stretching it far across the level, that will be a lot of processor power, having all those particles. If you can set a rain cloud to be repositioned, then you get this odd effect of the faster you go, the less rain is created in front of you, and the more you stay still, the more it rains. So people often cheat. So they get an active object and have an animation of rain falling, which tiles, so that you can create a whole area. And the layers toolbar is especially useful for this. We can then add a new layer, add in our rain effect, and make sure that the rain effect under runtime options is not following the frame. That's even less processing, but does mean you have to be good at art or get a good animation. More on layers coming up at this timecode. Shaders and layers. In this section, we're going to look at shaders, but also layers and how we can use them to help us with our shader effects. Now, shaders are a type of effect that can apply to an object to change the way it looks. In the summary, we looked at addition and subtraction, but in the full version, it comes with inverted, monochrome, even flipping the image. And these all can be added to. Out there on the internet, people have developed different shaders for ClickTeam to have very exciting effects, such as underwater or different types of camera lens. I'd head to the ClickTeam community forums to find out more about those. When we're selecting our effects, we can see extra information about them. We can see the hardware that they run on, so you can see if it just runs in DirectX in Windows, or if it also runs in Android, iOS and Mac. And we can also see a description of what the shader does.
Now, parameters are values you can change for the shader, which will change the way the effect works. These will appear in the Properties toolbar in Display Options underneath the effect itself. And these parameters can also be altered in-game in the event editor by having an action under the active object, under Effect. We can set the effect, the parameter to use, and if we want to apply an image file to it. Once again, these are all quite specific to the shaders themselves, so read up about the shader online. Let's go back to the effects and look at the shaders in regards to positioning. So we're going to select Subtract. So the Subtract shader will only affect that active object and any object beneath it. We can change the order by selecting an object and going to Arrange, Order, and Bring to Front. But that's not very useful for a couple of reasons. One, you might create other objects in the game, and those objects will have a higher order and be on top of it. Also, it gets confusing piling objects on top of each other and trying to select the one that you want. This is where layers come in. By default, the Layers toolbar lives on the side of the frame editor. If it's not there, you can turn it on under View, Toolbars, Layers toolbar, or Control and K as the shortcut. To add a new layer, we click on the white sheet, and this layer is placed above the current layer we're working on, and the order is very important. The higher up the layer, the more on top it is. To move our active object that has Subtract on it, I'm going to drag it onto the layer above that I want. And note, when I click on it, it says it's on layer 1 and then gives its object number. Now, if I pull it onto the Layers toolbar, onto the layer I want, you can now see it's on layer 2. And it resets the object numbers back down to 1 for that layer. If I reopen the Layers toolbar, you can see that I've currently got layer 1 selected and the object is in layer 2. I can now choose to lock that layer by pressing the padlock, and I can carry on with selecting objects that I want on layer 1 without any of the objects on layer 2 being in the way. I can also go one step further and I can press the I on any of the layers that aren't selected to turn them off. This way I can build my level without the distraction of other objects that aren't needed. Now, if my frame was expanded to be a scrolling level, as I walk out of the boundaries, we'll start to see the edges of that object that has Subtract on it. We could select our object, make sure you turn off the padlock first, and select our Subtract active object, and in the runtime options, we could turn off Follow the Frame. But far more useful and more powerful is to change the layers scrolling. So if we select the layer itself, layer 2, you can see it has settings itself. We can name the layer, which is useful for when we use a layer object, and we'll talk about that in the next video when talking about making larger games. But we can change the X coefficient and the Y coefficient of how much it scrolls. 1 is 100%, so it matches the scrolling, and 0 is not scrolling at all. If we set these numbers to 0, anything on layer 2 will not move at all, will not follow the frame. We can add in GUI, graphical user interface things, like a HUD or text, or other things that previously would have to change to not follow the frame. But anything on layer 2 has a 0 scrolling coefficient, so it's not going to follow the frame regardless. And looking at the settings for layers, you can also apply shader effects to a whole layer, and blending coefficient and RGB coefficient. So look back at those sections to see how to use them. Changing from a top-down game to a side-scrolling game, we can introduce something called Parallax by changing these scrolling X and Y coefficients. If we have the game of the character and the platforms on one layer, we can add layers of different background and foreground objects. Now, when we run the game, they will just scroll with us. But if we change the X and Y coefficients so that anything that's further away has a low coefficient and anything that's close by has a higher coefficient, it means that the scrolling is adjusted so that the background moves slowly and the foreground moves quickly. And layering it up like this allows us to make some really beautiful effects. A fake 3D kind of effect, which just means in a few seconds we can make our game much more immersive. Like we covered earlier at this time code, using layers allows us to make things much more advanced, for allowing rain behind and in front of the player at the same time.
While talking about GUI, Graphical User Interface, and HUDs, the heads-up display, it's also worth mentioning you can include another frame to be on top in the similar way to a layer. This means you can have one frame set up with all of your Graphical User Interface, and just in the frame settings, the option to include another frame, you can select the frame you want, and then in-game that gets overlaid, meaning total consistency with your Graphical User Interface between every level. You can adjust it once in your frame you're using to overlay, and it's updated across your whole game. Talking about special effects and talking about scrolling, screen shake. Now there's different objects that allow you to zoom into the screen. There's something called screen zoom, which can be used on apps and HTML5, and viewport that gets used in Windows devices.
Screen shake is something that doesn't need any shaders or special objects in order to work. It's just about centering the window position in the frame with scrolling. So I've set up a counter and called it shake. And whenever my tank character hits a background wall, it will stop, and I want to set the counter to be the movement speed of the tank. This will allow me to set the speed to the screen shake. So I run the application and drive into a wall, and each time I do, it updates the counter to what my speed was at collision. I've already added a condition of always center window position and frame relative to the tank object. This new condition will be the count shaker compared to a value if it's greater than 0. And for the action, if we right click under Storyboard controls, under scrolling, set horizontal position of window in frame, we'll get the X coordinate of the tank and we'll add in a random range. This range will be based off the shake counter. So on the shake counter, we'll get the current value, but then we'll times it by -1, and that will give us the negative version of the shake counter. Then I use Tab to select the maximum input and set it to the current value of the shake counter. And we'll repeat that whole process for the Y position. So right click on the same tick under Storyboard controls and center vertical window position in frame this time. And this time get the Y position of the tank, and again add in a random range, the current value of shake times by -1, and then for the maximum, the current value of shake. Now as this condition happens after always center window position in frame, it will override it if shake is greater than 1. Now shaking all the time is not the effect we want. We need to reduce the shake over time. So in the event editor, we'll add another new condition to do with the timer every 100th of a second. And for the action, we will right click underneath the shake counter and subtract value from counter. We'll try 2. The bigger the number we subtract, the quicker the screen shake will end. Testing our application, we get a very sudden shake as soon as we hit the wall. So what we'll do is we'll alter those values to adjust it. On collision with backdrop, rather than setting shake just to our speed, we'll times it by 0.1. So it's 10% of what the shake was previously. And on the timer condition, we'll subtract by 1 rather than 2. So it's a lighter shake, lasting for twice as long. All we need to do is move the counter off the play area or make it hidden, and we've got a fun little screen shake. This section about videos also works for other media files like MP3s and WAV, wave sound files. As we covered, there are lots of different video objects, but the Active Direct Show object works the best in most situations, as long as you're running your application in Windows. If you're having trouble playing certain files, it might be that you don't have the right codec installed. I recommend downloading the K-Lite codec pack. A codec is a coder and decoder to allow videos to be processed by the computer. Also, if you have a very large video file, you can use software such as Handbrake on Windows, which will convert your video into an MP4 format, normally of a much smaller file size, without losing much quality. When you insert your Active Direct Show object, by default it asks you to choose the file. When you do, the full file name path is put into the file name properties of the object. Now that's not useful if your game is going to play on a different system. What we can do is delete all the path, leaving just the file name, and the file extension, in this case intro.mp4. That way, as long as your game file is in the same folder as the video, intro.mp4, then ClickTeam will be able to find the video and play it. The one condition I want to draw your attention to is the is playing condition. Is playing is a condition to make sure that the video is playing. You can also negate it to see if the video isn't playing. This can be useful if you want an action to happen once the video stops playing or is paused. Another way you can check where the video is positioned is by going to New Condition, going to Special, and compare two general values. For the first value, we can use the active direct show get current position. This is in milliseconds. Now, if this is greater than the second variable, which we'll set to the active direct show duration, minus 1000, that way, when it gets to 1 second from the end, we can get it to trigger another action, in effect trimming the video down, shortening it by 1 second for what the player will see. I've created a playlist in a list object. For my condition when it gets towards the end of the video, I'll right click and under Special, I'll insert a limit to only run this action once while event loops, so that it doesn't keep triggering. And under the active direct show object, I will load, use an expression, and from the list I will get line number 1. And then I'm going to delete a line number 1. The list has been shuffled upwards, and what was line 2 is now line 1 again, so it'll work its way through the list, playing each video one by one until it gets to the end of the list. If you need to get some good royalty-free videos, I recommend pixabay.com, which is where I got my videos for this playlist from. Be aware, in the current version of ClickTeam I'm using, when I ask about the mouse user clicks on an object, it doesn't bring up the active direct show, but it does if I say the mouse is over an object. Then I can insert the mouse user clicks, left button single click, press OK. I'm just going to drag the left button single click above to put the conditions in the right order, and that will be the same effect as clicking on the video. I can then click under the active direct show and use the flags and toggle, and I'll just use flag 0. This way I can have a new condition to say that when flag 0 is on, the video plays, and when flag 0 is off, then the video stops. That way I can click on the video to pause it. You could also add other active objects in order to fast forward by setting the position of the video. And you could set controls for volume and looping, and make your own play controls. Videos are brilliant to add into the backgrounds. You could create a layer and put it behind your action. You can use them in title screens and menu screens, or you can use them for tutorials. Just make sure for ease, you put your video files in the same folder as your Fusion application so that Fusion can find the video. Saving and loading. As we said in the free edition, you're limited to just 2 objects that can load information. In the full version, there's actually a feature that will save the current state of everything in your frame. All your objects, all the positions, and all the alterable values. A proper save function. I'm going to create a new action in this pre-made game. New condition, mouse and keyboard. Upon pressing a key, S, then under the storyboard, I can choose frame position, save frame position. It then now wants a path to a file. Now, if we don't put anything in, it will open up a file selector to save. This feature is only available for Windows applications. Now, to make sure that it saves it in the same location as our folder, we're going to use, under Special, our application directory. And that's the folder that we're running the game from. And we'll just add that to save.mfs in those inverted commas. It will then ask for a version number. This allows you to have multiple saves in the same file. And that's all we need to do. We can then put a new condition, the mouse and keyboard, upon pressing a key, under the storyboard, under frame position. I can load frame position. This time it asks us to find the file, but we know it's going to be save.mfs. So I'll read app.$ plus and in speech marks save.mfs. Now that's fine for saving the frame and loading the frame, but if you're creating a load screen in a different frame, you'd want to use load application position, not frame position. If you want some basic control about what you're saving in the game, let me introduce you to the ini object. In the settings property, we'll set the name of the ini to be called save.ini. As I'm using a full version of ClickTeam Fusion, I'm going to add in an edit box. An edit box is a way for the user to be able to input their own strings. Like before, we'll have the condition of mouse and keyboard, the keyboard, upon pressing a key, S, and then for the action, right-click under the ini object, and we're going to set a value. And this value is going to be the score. So we will name it score, and we will get it not from the score object, but obviously the player object. We're also going to save the edit box text. So we'll right-click on the same tick, and this time set string. We'll name that name, make sure it's in inverted commas, and we will get it from the edit box, we will get the text. Now we'll run our application. I'll type in my name, I'll play it a bit and get a score, and then press S. Now let's find the ini file that we've just created. So by default, it's saved in your app data folder under roaming, under MMA applications for multimedia fusion. And there it is, save.ini. It's got empty brackets, that was the group we didn't use, but it's got the name and the score saved. Now if I get a different score, and I type in a different name, and then press S again, the ini file has saved over the new data. So now let's load it. Upon pressing a key L, so under player 1, we'll set our score, and from the ini, we will get the value of an item. And the name, the reference, the title we gave it was score, and loading the name. Under the edit box, we'll right click and editing, set text. To the ini, we'll get a string item this time, and that was called name. As always, make sure that you've got quotation marks either side of your strings. So both the score and the name will be loaded. I run the application, press L, and there it is. Name and score are updated. Ini files don't just save number values and strings, but you can also save the position of an object. So I'll do that for P1, our player object. And I'll do it again for the coins. Now we'll run into an issue here because there's multiple coins. And I'm pressing L. The action under the ini file is load the position of objects. So I'll run my application again. I will enter a new name and get a new score and save it. But look at the ini file. You can see it's only saved one coin position. Ini files will overwrite the name if it's the same as other items. So if there's multiple instances of the same items, it's only going to save the position of the last item. So when I load it, P1's position is set, but all the coins have been placed in the same position. All coins are placed on top of each other in that same position. So ini files work great if you're only saving individual items. But for our games, we'll need a cleverer solution to this. In this game, I have several different active objects and multiple instances of each. So I've placed them all into a qualifier group called reference points. And I've added in a list object. This is going to be used to record and recall all the data we want to save about each individual object. Their position, their direction, their speed, and their alterable values. So I've given player 1 an initial alterable value of 5. And as before, in the event editor, the mouse and keyboard, upon pressing a key S, we're going to save all of the data. We're going to reset the list so it's completely blank. Then it'll run a count loop for all of the objects that are in the qualifier group reference objects. See this video at this timecode. Then I add a line to the list. Let's have a look at what I add. I add the name of the reference point object. And then I add what's called a delimiter. I've used a pipe character. This character is normally found to the left of Z, shift and backslash. And I use it because the pipe symbol isn't ever used in the name of an object. It'll become important when we reload the file, split up this line again. Then I get the string values of the X and Y coordinates, put delimiters in between. I put the direction, the speed it's going, and ultra value A, all with delimiters in between, the pipe. And still with pressing S, under the list object, we use the action of saving the file in the application folder, app data $, and we call it save.sav. I run the game and press S. You can see I've got the name, I've got the X and the Y position, I've got the direction, and I've got the speed and the ultra value A saved in a list. And here's the file saved on my computer with all the information. I'll put it by the side of the game. If I press S again, you can see it updates. If you wanted your game to auto-load the last save point, you'd need to be able to check that there's a save file to load. I've used something called the file object. The file object allows you to do basic file functions, including checking if a file exists on your computer. So by inserting two conditions at the start of frame, I check to see if the save.sav is saved in my application folder. If it exists, I destroy all the current group reference objects. And it's really important to do that. So I start with the level afresh with none of the objects that I'm going to create already being there. Next, I do some actions under the list. I reset it, and then I load a list file, and I load the save.sav. I use that list, now that it's got all of the objects in, to start a fast loop. I've chosen to call it load. So I call the fast loop load, but I run it the number of times that there's the number of lines in the list. Let's look at the actions. I use an object called a string tokenizer. This takes a string and cuts it into parts based off a delimiter. For us, that's going to be the pipe. And we're going to split line number 1 of the list into individual elements, all numbered. Now that the string tokenizer has all of the individual elements of that line in it, I can now delete the line off the list, allowing the list to shuffle upwards. Then I can create an object by name. And the thing is, we know what the name is because it's held in the string tokenizer in the first element. And because it's 0 indexed, the first element is 0. If we have a look at the save file again, element 0 is going to be the name, 1 and 2 are the X and Y position, 3 is the direction, 4 is the speed, and 5 is ultra value A. And then when I position it, it doesn't matter because I'm going to reposition it when I set up all the data. So all the setup for that object we've just created is going to be an action underneath group reference points. So I set the X position to be element 1 of the string tokenizer. But that's a string, and strings and values don't mix. We need to convert it. So we'll use the value conversion on element 1. And then we do the same with the Y position as a value, the direction value, the speed value, and the ultra value. Now if I restart my frame, and I'll just keep on restarting it, you can see that even though objects are set to start in a random direction, they're always choosing the same direction because it's loading the data from the save file. So opening up the debugger window, if I load up P1 under the ultra value that was set to 5 initially, we can see it's set to -3 every time it restarts, the value from the save file that we made. And if I move around my world and save it again, it restarts with those new saved positions. This is a really powerful way of saving and loading and works across different platforms.
Well, that's all of it. That's special effects and files loading and saving. Next time we're going to be looking at building larger applications or games in Fusion, work together in a team, and be able to debug properly. So that's templates, teamwork, and testing.
See you then.